This lesson is going to be on solving system of equations by graphing. So first we're going to talk about what a system of equations is. A system of equations is two or more different equations with two or more variables. When you're solving a system of equations, we have to find a solution that's going to make all the equations true. It cannot just be true for one of them, it's going to have to be true for all of the equations. And we also have to make sure that we are all solving for all the variables. So if there's two variables, we have to make sure we're solving for both. 3 variables, we're going to solve for all 3 variables. The first way to solve a system of equations is by graphing. To solve a system of equations by graphing, we're going to graph all the lines, or all the functions, and our solution is going to be the intersection point, because that means that's where all the equations are equal to each other, at that intersection point. Solve this system of equations by graphing. So I'm going to graph each line separately and then look for my intersection point. First, I'm going to graph y equals 3x minus 4. It's in slope-intercept form, so I can identify my slope as 3 over 1 or negative 3 over negative 1. And my y-intercept is negative 4. I'm not going to worry about the second function yet. I'm going to fully graph the first one, then move on to my other function. So I'm going to begin my graph at negative 4 on the y-axis, up 3 to the right 1. I'm going to keep plotting as many points as I could fit on my graph so that I get my best possible graph. Now go the opposite way, down 3 to the left 1, down 3 to the left 1. I'm going to connect my points with a straight line, and I'm going to make sure to label my equation. So this is y equals 3x minus 4. Now my other function is also in slope-intercept form. So here my slope is negative 1/2, so that's negative 1 over positive 2, or positive 1 over negative 2. And my y-intercept is 3. So now I'm going to begin my graph at 3 on the y-axis, down 1 over 2. And even though I have a point where they intersected, I'm going to keep plotting as many points as I could fit. Up 1 over 2, now going the opposite way. Then I'm going to draw my line connecting my points and make sure I label it. So this is y equals negative 1/2 x plus 3. Now I'm going to circle my intersection point to show that that's my solution. And I'm going to write my solution as an ordered pair. So that point is 2, 2. So that would be the solution to this system of equations, meaning x equals 2 and y also equals 2. Solve this system of equations. Both of them are in slope-intercept form, so I can identify my slope, negative 2 over positive 1, or positive 2 over negative 1, and my y-intercept is 2. So I'm going to begin at 2 on my y-axis, down 2 to the right 1. And I'm going to plot as many points as I can fit so I have my best graph. You can also go the opposite way. I'm going to go up 2 to the left 1, up 2 to the left 1. Connect my points, put arrows at the end, and make sure I label it. This is y equals negative 2x plus 2. Now my other function is in slope-intercept form. So my slope is negative 2 over positive 1, or positive 2 over negative 1. My y-intercept now is negative 2. So I'm going to begin my graph at negative 2, the y-axis, down 2 to the right 1, down 2 to the right 1. Now go the opposite way, up 2 and to the left 1. I'm going to plot as many points as I can fit to get the best graph. Connect my points, label my function, y equals negative 2x minus 2. Now if I notice, my lines never intersect with each other. So that means that this function, or this system of equations, is going to have no solution. And when I looked at the beginning, I could have saw they had no solution because my slopes were the same. So since they have the same slope, that means my lines are parallel and are never going to intersect with each other. Solve this system of equations by graphing. So my first function is in slope-intercept form. So I can just state what my slope and y-intercept is. So my slope is negative 1 over positive 2, or positive 1 over negative 2. And my y-intercept is negative 2. So I'm going to begin my graph at negative 2 on the y-axis. And then I'm going to move down 1 to the right 2. And I'm going to plot as many points as I can fit. Once I run out of room, I'm going to go the opposite way, up 1 and to the left 2. Connect my points to form my linear function and make sure I label it. This is y equals negative 1/2 x minus 2. Now for my other function, still in slope-intercept form, now my slope is negative 3 over positive 2, or positive 3 over negative 2, and my y-intercept is 2. So I'm going to begin at 2. Now I'm going to move down 3 to the right 2, down 3 to the right 2, down 3 to the right 2. Same thing. Put as many points as you could fit. Now I'm going to go the opposite way, up 3 and to the left 2, up 3 and to the left 2. Connect my points. Make sure to label your function, y equals negative 3 over 2x plus 2. Now these graphs do intersect, so I'm going to circle my intersection point and write my solution as an ordered pair. So my solution would be 4, negative 4. And task 3. Now we have a word problem that we have to write a system of equations for and solve it. So Creative Crafts gives scrapbooking lessons for $15 per hour plus a $10 surcharge. Scrapbooks Incorporated gives lessons $20 per hour with no additional charge. Write and solve a system of equations that represents the situation. So first I'm going to identify my variables. Y is going to be the total cost, and X is going to be the number of hours. And since I have two variables, I'm going to need two equations. So I'm going to write an equation for Creative Crafts. Since they're $15 per hour plus a $10 surcharge, that means it's 15x plus the $10 surcharge equals the total, which is y. And Scrapbooks Incorporated is just $20 per hour, so that's going to be 20 times x is equal to y. Now my axes aren't labeled, so I have to determine how I should number them. Before I do that, I'm going to determine my slope and intercept of both lines to see how my numbers are moving. So for Creative Crafts, my slope is 15 over 1, and my y-intercept is 10. For Scrapbooks Incorporated, my slope is 20 over 1, and my y-intercept is 0. So I notice that my slope is moving by 15 and 20 and starting at 10. So to space out my graph, I'm going to number every other line going by 5s. You want to try to go by as small of a number as possible so that it spaces out your graph and you're able to read it clearly. And now my y-axis, the hours is just going by 1, but since my graph seems a little small, I'm going to alternate every other line going by 1. So each line is going by a half. I'm just going to keep that in mind as I graph my function. So Creative Crafts starts at $10. So that's my y-intercept. And then it goes up 15. So it goes up 15. Make sure you're counting by how much you're going up. So if it's at 10, it's going to go up to 35 and over 1. Up to 25. Sorry. Up to 25 and over 1. And then if it goes up 15 again, it's going to go up to 40 and over 1, but it's really over 2 spaces in my graph. Then it's going to go up to 55 and over 1 hour. I'm going to draw my line and I'm going to label it. I can either label it with Creative Crafts or I can label it with my equation, 15x plus 10 equals y. Now for Scrapbook Incorporated, that starts at 0. And now it's going to go up by 20, so it goes up to 20 over 1 hour, up to 40 over 1 hour, and then up to 60 and over 1 hour. So I'm going to connect those points, label this function, so this is Scrapbooks Incorporated. Now notice they intersect with each other, and their intersection point is 2, 40. So it says to interpret the solution, so that means 2 hours cost $40 at each store.